Okay, this is the Thursday lab session on September 16, 2021. Okay, so let's take a look at your notes. Let me switch here to my laptop. I didn't switch? Yeah, I switched it, right? Good. Showing there. Let's take a look here at the notes. Zooming. Today is the, let me copy and paste down there. Insert. Oops. Then I don't, here we go. Now it should go good. Today is the 16th. Okay. So the first thing you gotta do is to plot 3 different graphs. Have you done that already? I don't hear anything. No?
I've only plotted one. There was one of them elements was something about an equation, right? Something I didn't
Yeah.
understand.
Yeah, we're gonna get there. We're gonna get there. So yeah, okay. So let's plot those 3 graphs. But before we start plotting the graphs, I want to see group 1. Who is group 1? Okay, group 2. Okay, group 3. Group 4. Group 5. Group 6. Do we have group 7 as well?
Yeah.
Ah, we have group 7. Okay, I would like to do the following so I know where you folks are located, right? I did that with the Tuesday section as well. I want group 1 here in the extreme left, group 2 right here, right? Group 3 here in this row, 4, 5, 6, 7. Okay? So I know where those are located, right? Everything. Randomly located. Quatro. Okay. Group. Which group are you? Okay. Group number? 4. What? Okay, good. 5, 6, 7. Good. So it looks like we have. Okay, so the first thing you gotta do is to plot the mass versus volume for the ruler, mass versus volume for the vernier scale, and mass versus volume for the micrometer. Let's start with that. And and then we can do the other stuff as well. And let's not forget, here you go, you have this valve, and you should label just exactly the way I'm doing here. P37 Thursday, right? L01G and your group number. 1, 2, 3, 4, 5, 6, or 7. Okay, because I don't have a group, I'm gonna put my group as being group 0. Okay, so here you go. Do you want to rename it? Yes. Interesting. Okay, so here you go. I don't have any data there, right? But let's wait. Come on. Loading. Good. Here is my. Okay, so first thing, right? Oh, first thing, let's fill up this table. Okay, first thing, get the density of steel from the internet. If you have a range of values, just get the average value of that range. Okay, and then you fill that up here. Just put a number there. Don't put the in units. The units are already here. See that? And the units should be in kilograms per cubic meter. Do that. And then at this point in time, you must have the diameter of the spheres, right, of the balls, plus their masses, right? Everybody has that, right? Okay. So if you have that, now you can plot the mass versus the volume for the ruler. I want to see that. Then the mass versus the volume, 3 different graphs for the vernier caliper. And then the mass versus the volume for the micrometer. Okay? Let me go through each group to see what's your situation, right? So, group. Okay. I'm gonna copy and paste it right in here. I wanna see where you are in terms of the plots. Okay, graph 1, 2, and 3. 1, 2, and 3. Insert. Okay, graph 1. Group 1, did you do the graph for the ruler? Yes? Okay. What about the graph for the vernier caliper? Yes? Okay. What about the graph for the micrometer? Yeah? Okay, good. So here you go. Group 1 seems to be in good shape. But then you gotta get the trend line. Did you do the trend line, group 1? You did all the trend line as well? Okay. And there's 2, oh gosh. 2, 3. Okay. And then we have to do the confidence level table that you still do not know, okay? The trend line, for the trend line was that, the equation and the R square. You did that? Okay. So let's go group number 2. Did you do did you do the first graph, group number 2?
The first graph, yes.
What about the second graph?
Yes.
Yes, third graph?
The third graph I'm working on.
Okay, good. So I just want to see where you are, so you're not in the trend line yet. Group number 3. You do the first graph.
Yes.
Second.
Yes.
Third.
Yes.
Trend line.
Yes.
R square and equation.
Oh yes, it's in the graph.
Okay, it's in the graph, okay. And then, okay, so we're gonna do the CL together, okay? So hang in there. Group number 4, graph 1.
Yes.
Graph 2,
Yes.
graph 3,
Yes.
and the trend line.
Not yet.
Not yet, okay. Trend line and R square, right? So group number 5, graph 1. No? Okay, okay, so go ahead. Okay, so go ahead, no, not yet, right? So you didn't do graph 2, you didn't do graph 3 either, right? Okay, so go ahead, start working on that. Okay, so we can. Group 6. Did you do graph 1?
Yeah, it's all good.
2,
Yeah.
3,
Yes.
trend line.
Yeah.
Trend line and plus R square, right? The equation plus R square. Okay, so hang in there and I'll show you how to do the CL. Group 7. Group 1 now?
We haven't done any of the graphs.
Okay, so but you have the data, right?
Yes.
Okay, so start working on the graphs. Graph 2. No, no, okay, you didn't do any of the graphs, so okay. So start working on those. How many you have? Most of you have done the graphs. Only 2 groups didn't have any graphs. Okay, so and then when you plot the graphs, make sure for those who have done the graphs, right? Make sure you have the axis title, right? Do you have the axis title? All your groups, right? Make sure you have axis title in your graphs. Axis title. Yeah.
So if we can, do you think it's possible if we can redo our caliper because we messed up on it?
Okay. Yeah.
It's the clamp one, right?
Okay. Which group are you?
5.
5. Let's see here. Group 5. Yeah. Okay. Let me get the. Let me get the. I need no, not this one. I want this one. I'll get that for you. Hang in there. Okay, that's good. Okay, while you are at that, I once, if you folks, you know, do something else too, in addition to the plot in the graph, download document in shareable folder, confidence level.pdf. Okay, let's see where it is. I have it right in here. Everybody, download this document. You don't have it yet. 37 nodes. You're gonna need that for one of the tables, and in this meantime, let me get something for the group number 5. Does it bring a calculator? Only bring a calculator or all the micrometers? All of them? And the ruler? Yeah.
Are you doing mine? Which one?
Usually I click here, like Excel, but I can't get into the Chromebook. It didn't let me download Excel. Yeah. It's like,
Wait, you didn't have it coded or no?
not on this, I just think it's a different operating system. You know, like Excel, I think you have to use Windows, right? It's just a Chrome operating system.
Mac.
You can, yeah.
Well, you have
This is a Chromebook, so I think it's Chrome OS.
you have
Doesn't have what?
you have an iPad.
Because right now I'm using the school, the P35,
Uh-huh.
and usually it'll say over here add chart element, and it'll say like add a trend line, and it'll say add the R square. It doesn't have that. This is like what the browser recommends you add. So I was trying to add a line here using this,
Uh-huh.
but what it does is it does that, and that's not what I want.
Yeah.
So that's what I'm trying to
You
figure
want
out.
maybe what do you call it? Google Sheet Fabric.
It might. Let's see. I'm gonna try switching browsers. Because I had done it on my home computer, which is Windows.
Yeah.
But then when I saved it, saved the chart, it was all just a straight line. What like what I did with the formatting and all that stuff. So I had to redo it. Yeah, let's try this. I can try sending it while at his place, and then we'll see how this sounds.
Average the trend line. Anybody else need to do additional measurements? Everybody else has their data. You're in good shape. If you need to make any measurements, let me know. Okay. Go ahead, get ready. This one, and let me. Oh, no, let me. Don't forget, it's this knob here, right?
Yeah.
It's okay to unscrew by holding it. What's not okay is to close it. Okay. Sometimes you get locked when you completely. Okay, so get those two, and let me get these fuse that you need.
So the last one should be like a very tiny, the
Yeah,
tiniest.
I'm trying to find it here. Um, okay, start with those. Here you go, group 5. Start with those for now. There are 4 only. Okay, I'm trying to find. Hey, wait a minute. No, that's okay. Yeah, hang in there. I need those fuse here because I need to know which one I have, which one I don't have. Mm. This is got sync. Mm. Okay, here you go. I got it. English is got sync 6, group 5, right? Okay. Group 5. Use. Okay, so let's see. Group 5 a little bit behind. Group 7 is also got a plot in there. Trend line. Okay, group 5 and 7. Whenever you have finished the first graph, let me know, okay? Yeah. First one, okay, you're group 7, right? Okay, good. Group 5, you're still making some measurement. Do you have the first graph, group 5? No, you don't have the first graph? Okay, finish at least the one graph so I can start talking about the CL table. Okay, so trend line and R square. So here you go, that's this one right in here. Talked before, okay? We're going to start talking about something we didn't talk before, and it is related to that file that you downloaded. Make sure you have the confidence level file downloaded. Here you go, on the shareable folder. This one right in here. Okay, I'm going to download it myself, and then I'm going to open it. Okay, here you go. That's the file. I'm going to explain. I have a better document. Okay, I'm going to, here you go. Note that in your file, you have the following. You have the column for n. Let me change something here. I want you to understand this table. You gotta learn how to use this table. Okay, here you go. You have the data for n. See that? 3, 4, 5, 6, 7, 8, 9, 10. It starts at 3. N starts at 3. Okay. Look at the CL table. I'm gonna write it down. Look at the confidence level table. You have the following. One column for n. Okay, this column for n. What's this column for n? Is which is the number of data points in your graph. Okay? How many data points do you have in your graph? 6. Okay? So that's what we have there for the first column. N. Then we also have another parameter here that I put df. Okay? This df parameter means degrees of freedom. That's what it means. It's not, it's just there for redundancy sake. df is related to n. Do you see the relationship between df and n? Degrees of freedom and n. N is 3, df is 1, right? So there's a relationship between them, right? N is 4, df is 2. So df degrees of freedom is what? Minus 2. Is n minus 2. Why it doesn't do that? Let's see. This one. Here you go. I got it. Okay. And then you have CL here and you have alpha here. See that? CL and alpha are in the horizontal lines. Make sense? DF and N are in the vertical columns. Alpha and CL are in the horizontal cells here. And then we have the values for CL. CL is 0.95. But alpha is 0.05. See, there is a relation between CL and alpha as well. So we have a redundancy here as well, okay? Similarly, CL plus alpha will always be equal to 1. I'm going to tell you what CL is very soon. Here you go, 0.99, 0.01. See that? We're going to be using that. 0.999, 0.001. See that? And so on. Okay? This number, as you go to the right, gets closer and closer to 1. I don't need that. Okay, that's one time. Okay, that's one. I'm gonna put that in scientific format, so you know what you're doing. So it's easier, right? This one too, I'm gonna put in scientific format. All of them, I'm gonna put in scientific format. Format cell. I'm gonna put just one decimal place there, so it's not that true. Okay. But look at the PDF document that I showed to you. It looks just like that. Okay, and my PDF document stops right in here. You see that? Let me open that, the PDF document, confidence level. Okay, go to 10 to minus 7. Okay, so it doesn't look like I have 10 to minus 7 there. Let me put 10 to minus 7. Yeah, I stopped at 10 to minus 6. I don't have the data for 10 to minus 7. But you're gonna learn, okay? Yeah, I put 10 to minus 43, which is almost 1. Yeah, for some reason I didn't put 10 to minus 7 here. Okay, so here you go. NNDF, alpha and CL. Okay? What about the rest? What about the rest of this table? Okay, the rest of this table is the R square that you found there in your graph. Make sense? What I want you to do here in the second table, what I want you to do in this second table is to find out what the CL is. And notice that I have a minimum and maximum values for the CL. Actually, a better way to write it down should be lower and upper bounds. Okay, that would be a better description for CL lower, CL upper, lower bound of CL, upper bound of CL. So let me explain. So what we have, what you have to do here first before you go to the CL, write down the number n, right? N is going to be 6 for everyone. Fill up this table. Can you do that? And number. Okay. What's going to be m here? M is your regression equation. You got a linear relation, right? Which is pretty good, right?
The trend line?
The trend line. Just just type your trend line. You know, the slope times the v plus the intercept. Okay. And here is obvious, right? It's the r square. Type the r square there. Okay. And now we are going to use r square and n to find out the CL. Let's see how we use that table. Many students, they get a little bit. So suppose, I'm gonna write it down here. Suppose I have the following. One column for n, one column for df, or degrees of freedom, which is equal to n minus 2. Oh, one row for CL, and CL, by the way, stands for confidence level, or confidence level. One row for alpha. Alpha. There's a name for alpha, but I'm not gonna tell you what it is because I don't remember the name for alpha. Okay, and what else? The body, in the body of the table, we have what we call the critical value of r square. That's what we call it, critical value for r square. Okay? So most of your table is just r square. Most of your table is r square values. And now we're going to learn how to use this table, okay? So suppose go group 5. In your graph, n is equal to 6, right? So when you're going to use your table, what you're going to do? you're going to pay attention only to this row. Make sense? Only to this row. And let's say you have r squared. That's exactly this value here, exactly. You know, let's say that r squared is equal to this value. It's not gonna happen, by the way. You're not gonna get a value exactly like that, okay? But just for the sake of an exercise for you to understand how this table works, suppose that you were lucky enough and you got exactly this value r squared. What's gonna be the confidence level of your data, okay? So you go to your table, you got this value here, here you go. I'm gonna highlight it. This one, right? And I'm gonna highlight this one here in the vertical as well. That's your r squared that you got, right? So your confidence level, your CL for your data points is gonna be this value right in here. Make sense? 0.999. Confidence. What is the confidence level? The confidence level has an important interpretation. A very important interpretation. So here we go. So let's say r squared from the table, from the table, your CL is 0.999, right? Now the next question, what's the interpretation for the CL? Okay, CL, here you go, is a measure of how close your equation, okay, there's a name for the regression equation, how close your regression equation is to your data points. Make sense? CL can be anywhere between 0 and 1. Can be anywhere between 0% and 100%. Okay? Here you go. CL equal to 0 means that your regression equation does not fit your data points at all. At all. CL equal to 1 or 100%, here you go, means that your regression equation fits perfectly your data points. Okay? In our experiment, you will never get a CL equal to 1, but you're going to get it close enough. It's going to be very close. The experiment that we perform here is, in general, 95% or higher, the CL confidence level. Make sense? Okay? So here you go. Your data points, here you go, that you collect in your experiment is a description of real life. Okay? We can put this way, real life. Whereas your regression equation is a mathematical model of real life. Okay? The closer your CL is to 1, the closer your mathematical model is to real life. Okay? That's how you interpret the CL. Make sense? So the CL, furthermore, CL, by the way, is a function of the number of data points and r squared. That's why you need those two values to find the CL. Okay? It's a complicated function. It's not an easy function. That's why I give you this table for you to get an interpretation. Okay? So now let's do one more exercise. Let's say your CL is not that value, but it's 0.99484, right? 0.99484. 4. Where did I see that? Huh, interesting. Okay, I don't find it. Okay, let's see is instead of is something like that. Another exercise just for you to let's see. Hey, wait a minute. This table is different from what I have. Oh, what a shame. I just figured that out, folks. I have r squared here, but I do not have r squared there. Yeah. See, the numbers are not the same. See that? I just found that out. I'm sorry. That's my mistake. Let me see. I'll fix that right now. I'll fix that right now. 6, 5. Yeah. Okay. So, yeah. Oh, man. What a... So embarrassing. Okay. The way I'm going to do is the following. Did you see the numbers are not the same? Yeah, see, I put the critical values r. I didn't put r square. The numbers are not the same. Okay. So what I have there in your PDF file is the square of those numbers. Okay. Those are not the r squared. Those are just r. So let me fix that for you. I'll fix that for you right now. So I just noticed that. Here you go. Now what I'm gonna do? Let's see. This one. I'm gonna get this guy. Highlight the previous one and square it. Okay. And now you should have the check if you have the right values or not in the first column. Do you have the right values? Does the values match your PDF file? It does, right? I'm gonna check that for you as well. Here you go. 6.65, 0.84. Nobody noticed that, huh? Yeah, 0.84. Okay, good. Now I got it right. Now I got it right. So we're going to repeat the first exercise. We're going to repeat the first. So it's not what I had before. It was 0.94881. Okay, 0.94. Here you go. Yeah, supposed to be 0.94881. Do you understand what where the mistake was there? Okay. Now let's do another exercise. Okay. We're gonna do only two now from the table. See how it is 0.999. Okay. So another example, another exercise. Another exercise. Looking at your table, at your PDF table. Suppose that now you have n equal to 8 and r squared equal 93,219. Okay? What's going to be the CL? Another exercise. N equal to 8 and r squared equal to 93,295. What is CL? What is CL? Okay. You get that already? Take a look at your table. Find CL. I'll give you like 2 minutes. 1 minute. No, you can do that quickly. Confidence level. Okay, so here you go, n equal to 8, right in here. Okay, and 9321. Here you go. 9321. What's your CL? Do you see what your CL is? Here you go. Right in here. Right? 99.99%. Okay? Did you learn how to do that? How to use this table?
Yeah.
Okay, so that's the easiest type of exercise I'm gonna see. But the actual, exercise that you're going to see during your experiments is not gonna be that. Okay, it's not gonna be the exact R square. When you perform your experiments, you will never get those exact numbers. Only if you're remotely lucky, you're going to get exactly 0.65837 or 0.84126 or 0.94881. I have never had a group of students that got exactly those numbers here in the table. You're always gonna get something in between those two, between those two. Do you get the idea? Between those two, okay, and so on. Okay, so let's do another exercise here. Now suppose that you got a r squared n equal to 6. Okay, equal solution. CL is equal to 99.99%, right? That's for the previous one, which is 0.9999. Okay. Now real life example. Real life example. N equal to 6 and r squared equal to 0.97. Yeah, 0.97. I gotta get you. Yeah, here you go. 0.97. Easier one. Find the upper and lower bounds of your CL. Okay? What I call the minimum and maximum, or what I call the maximum and minimum. Max and minimum. That was I wrote there in my spreadsheet. Max and minimum. Okay? So let's do that together. Here you go. I'm gonna do this in the spreadsheet and then you do on your own, okay? N equal to 6, right? Let's go, highlight it. I'm gonna highlight here in my spreadsheet. Here you go. Your R squared lies between those two values, right? 0.94. So what's gonna be the bounds of your CL? Your CL lies somewhere between 0.999 and 0.9999. Make sense? You log this one as the minimum value or the lower bound. You log this one as the maximum value or the upper bound. Okay? My table cannot tell you exactly what's the CL for this specific value because my table is finite. Right? Make sense? So your answer will be, between those two values. So now I want you to do that on your own, right? Now you have your data. You may have your, here you go. You may have already your R squared and N. You'll be able to find out what is the CL for each graph that you have. Okay? That's what I want to tell you about the CL. Any questions about that? Okay, so lower bound or minimum, right? And maximum. So what you see there in your table is something like that. 1 minus 10 to minus 2, 1 minus 10 to minus 3, okay? 1 minus 10 to minus 4, right? So you go ahead. If you find that is 1 minus 10 to minus 3 for the lower bound, I want you to learn that how to do that. You're gonna type like that. You're gonna type equal 1. Let me see what I got in my example. My example was 1 minus 10 to minus 3, right? Equal, remember, minus 10 to minus 3. Okay? Don't forget to put the equal there. And the other one's going to be equal 1 minus 10 to minus 4. Okay? Don't forget to change the format of those cells. So you can see, put it in numeric format and put in this case 4, 5, or yeah, I believe we need only 4. Yeah, and now you can see the actual number, right? Use the numeric format and put 4 or 5 or 6 decimal places so you can see the whole number in there. Don't worry about significant figures. Everything in red, you do not need to worry about significant figures, okay? Here too, you don't need to worry about significant figures here either, because you got that from the table. I gotta put that in red. Come on, man. In red. Here you go. Put that in red as well, okay? Everything else, you gotta worry about significant figures. All the numbers that goes here, you put the significant figures. Okay, so that's what I want to tell you about CL. Oh, there's one more thing, very important to important here. What's the practical application of CL? What's the practical application of CL? Okay, if you're in the business of launching rockets, for instance, or building airplanes, or building cars, not just cars, but anything, building anything, devices, people test their devices to find the confidence level of your device. Okay? So let's see. A Boeing 777 has a confidence level that's higher than a little Cessna, single-engine Cessna. Okay? Do you know what single-engine Cessna is, right? Those small airplanes that private pilots fly out there. A Boeing 777 is far more reliable than a single-engine aircraft. Why is that? Because the Boeing 777 is carrying 200 passengers in there. Imagine if you're less reliable than a Cessna. Imagine if your Boeing 777 were less reliable than your car. You'd have a bunch of people being killed out there, right? So because of that, the manufacturers of airplanes, they must ensure, big airplanes, they must ensure that they are flying at a confidence level that's very high, very close to 1. Otherwise, they're going to have a bunch of lawsuits and they're going to have to file for bankruptcy. Do you get the idea? So if Boeing is operating right in here, and there is a, if Boeing is certified to operate right in here, and there is a lawsuit, they will have the money to cover the lawsuit. Okay? But suppose that you are a small aircraft manufacturer, okay, and you are certified to work right in here, and yet you start to sell your services stating that you can operate right in here at this level. You're going to have far more accidents than a Boeing company, and you won't be able to survive the market. And people can find out what the confidence level they are acting just by testing their equipment, okay? When NASA was flying astronauts to the moon, they were testing their engines, they were testing their systems to find out what was the confidence level of each of those components. And so from that data, they could come up to the president and say, look, we have a confidence level here that our astronauts are going to survive. We're going to have a 95% probability of surviving a round trip to the moon. And that was NASA was trying to do at that time. They were trying to get a 95% confidence that their astronauts were going to survive a round trip to the moon. And they were using all that table to find that out. Okay. Later on, NASA discovered that they were not operating at 95% confidence level. Later on, they discovered that they were operating more like at 85 to 90% confidence level, because we have astronauts that died, we have moon missions that had to be canceled and had to be aborted too, just like Apollo 13. Okay. So that's the whole idea behind the confidence level. Okay. And do not think that the small numerical difference here between this confidence level and this confidence level doesn't matter. It matters a lot. It matters a lot because here it might be a lawsuit that's $100 million, and here might be a lawsuit that's only $10 million. Okay? The numbers, the difference is small. Apparently small, but it tells you a lot about what you should expect in case your equipment, your product fails out there. Okay? So that's a practical application of the confidence level, and we'll be working with that for the rest of the semester for every experiment. Any questions about that? Okay, so that's what I wanted to tell you, and now you should know how to use confidence level, right? Okay, so go ahead, fill up your table for confidence level, and here you go, right in here, right? Here's just an example, don't forget. I'm gonna erase that. And let me see how is everybody's doing right now. Let me put a pause, momentary pause. Just a quick review for the regression equation, right? Here you go. I'm going to come up with a genetic plot, okay? Here you go. So let's say you want to plot X, right, and Y. So here you go. I'm going to create some data here, you know, some arbitrary data. Okay, so here you go. 2, 4, 3.6.1, 8.3, 9.8, 9.8, and 12.1. Okay, so here you go. You already know how to plot the graph, right? So here you go. Highlight those two, insert. So follow exactly what I'm doing. Plot the graph, right? Here you go. Click one of the data points. When I get the regression equation, click one of the data points. Everything should be highlighted. All the data points should be highlighted. Right click on one of the data points, add trend line. Did you do that? Okay, and then here you go, let's wait. Oh, here you go, linear, right? Linear is highlighted there. And you go down here in the pane, display equation chart. Display R square on chart. Okay? And then we have it. Right? Got it? It's that's spelled out in the syllabus as well. The step by step is spelled out in the syllabus as well, okay?